In second year, first semester, there will be a subject called as engineering mechanics, which is very useful for mechanical students as well as civil engineering students. We are discussing about the rigid bodies in this topic, and it may be R19 syllabus. First is about engineering introduction about the mechanics, introduction about the mechanics and the friction mechanics. Two topics are there: introduction as well as friction. It is created by me, M. Mularo, Assistant Professor in Mechanical Engineering Department, JNTR. First, what is the hierarchy of engineering mechanics? What is the division of engineering mechanics? Engineering mechanics is subdivided into two topics: mechanics of solids and mechanics of fluids. Solids, fluids. What is meant by mechanics of solids? What is meant by mechanics of fluids? Mechanics of solids has been divided into two categories. You know that solids are more strength, that has more strength. Whenever there be more strength, it has been resist more number of forces. But fluids doesn't resist any type of forces. Solids, the intermolecular structure is very high. The intermolecular structure between the bonds is very high. Bonding structure is more. The bonding structure is very less. Whenever bonding structure is very less, there may be deformation happens. The deformation happens, then there may be external forces acting. There won't be deformation acts. That is the major difference between the fluids and solids. Solids, fluids. First, we are discussing about mechanics of rigid bodies. Mechanics of rigid bodies, which is nothing but a branch of engineering mechanics. Next, mechanics of deformable bodies, nothing but a strength of materials. This is subject called as strength of materials, which is discussed in second year, second semester. Now here we are dealing with the mechanics of rigid bodies. What is meant by rigid body? Rigid body is a body which can deform, which cannot be deformed, and there may be external forces has been acting. And there may be external force acting. There may be no deformation. Such type of bodies are called as rigid bodies. The bodies, such type of bodies are called as rigid bodies. But in a universe, there may be no rigid bodies. We are assumed the body is rigid body in engineering mechanics. Mechanics of deformable bodies, nothing but strength of materials. Discuss later. In second year, we are going to discuss that subject of deformable bodies called as strength of materials. Rigid bodies has been classified into two categories again. What is meant by statics? There will be two categories: statics, dynamics. Statics, dynamics. Again, dynamics has been divided into two categories. There are kinematics, kinematics. Kinematics, kinematics. Now, mechanics of deformable bodies also categorized into two types: going of elastic bodies, theory of elasticity, and theory of plasticity, which may be in third year. In third year syllabus, we are going to discuss these two topics. That is about theory of elasticity and theory of plasticity. Design subjects. Okay. Mechanics of fluids. There may be three types of fluids are there generally: ideal fluids, viscous fluids, incomplete fluids. What is meant by ideal fluids? I discussed in second year and third year 3-month subject, fluid mechanics and hydraulic machinery, and they are going to discuss about these subjects. These two also I am dealing this subject also. Mechanics of fluids also taking my videos. In my videos only we are going to discuss about mechanics of fluids. Okay. Now the major thing is in engineering mechanics we are going to discuss about mechanics of rigid bodies, about statics, dynamics, as well as kinematics, kinetics. We are going to discuss about both the statics as well as dynamics. Going to the next slide. What is meant by engineering mechanics? What is meant by engineering mechanics means it is a branch of physical science which deals with behavior of bodies which are at rest or in motion. It is a branch of physical science which deals with behavior of bodies, means behavior of rigid bodies which are at rest or in motion under the influence of external forces. Those are studies called as engineering mechanics. What is classification? What types of engineering mechanics are there? What are the different classifications of engineering mechanics are there? Engineering mechanics are broadly classified into two types. We are already discussed. We are already discussing higher in our classification. Classification of engineering mechanics. Lateral video, lateral discussion also about that one. Two types. Two types of classifications are there. What are they? First, statics. Statics in the name itself, stat. Now there may be stat. There may be the body is at rest condition. It is called as statics. Next one is called as dynamics. Dynamics in the name itself, dynamic means nothing but a motion, motion of a body. We are going to discuss about two types: statics and dynamics. What is meant by statics? We had very good slides. We are going with very good knowledge about this one. Statics is a branch of mechanics that deals with study of objects which are at rest. The branch of science, branch of mechanics are a branch of science, no problem, that deals with study of objects which are at rest or which are at rest. Object at rest may or may not be under the influence of forces. And there may be a force acting, the body is at rest. And there may be no force acting, you know that the body is in rest only. There may be force acting, the body is also in rest condition. Those studies called as statics, those called as statics. Dynamics. Dynamics is a branch of mechanics. This is also one of the branch of mechanics, which deals with study of objects in motion. Now the study of objects in motion and the forces act causing such motion. Dynamics is a branch of mechanics which deals with objects, means study of objects in motion whenever traveling one place to other place is called as dynamics. The forces which causes the motion, and also we are considering the force also. Those are called as dynamics. Again, dynamics has been classified into two categorized. What are they? Types of dynamics. Dynamics are further classified into two types. What are they? You know that kinematics. Next word about kinematics. Kinematics and kinetics. Comes to kinematics. Kinematics is nothing but, what is meant by kinematics? Kinematics is a study of motion of bodies, which is study of motion of bodies without considering of forces. You know that dynamics is nothing but a study of motion of bodies by considering of forces or without considering of forces. Static also study of rest bodies which are by considering of forces or with forces. But kinematics is dealing with only study of motion of bodies without considering the forces acting. Okay, without considering the forces acting. It deals with space-time relationship of motion of a body. Okay, it deals with space. Space is nothing but distance, time. You are looking for a time with which time they are being going and coming and going, motion has been happens. That relations has been studied about in kinematics. Generally, kinematics is nothing but we are going to discuss about the motion means displacement, velocity, acceleration. Suppose when you are traveling in a bus, the bus has been traveling from one place to other place. There may be no motion, no force are considering. That is called as displacement. Velocity. Velocity means the bus is traveling with some velocity. We are not considering the forces. Just we are considering the speed. Speed is nothing but acceleration. Now it has been accelerating. There has been accelerating with some speed, with some displacement, some acceleration. That means we are considering only the acceleration. We are considering only the motion, but not the forces. Forces we are not considering the forces. We are not considering the acceleration forces. We are not considering the gravitational forces. We are not considering here. So it's called as kinetics, which is Opposite to kinematics. Kinetics is a branch of dynamics. It is also one of the branch of dynamics, which deals with motion of bodies, which is the study of motion of bodies by consideration of forces, external forces, by consideration of external forces acting on them. That is called as kinetics. Okay, this is about the kinematic and kinetics. We are going to discuss in engineering mechanics both the kinetics as well as kinematics, as well as statics also. Statics maybe first to second units are statics. Next two should be about the 3, 4, 5 units are about the kinematics and kinetics. We are discussing about 14 units should be kinematics and 15 units should be kinetics. Examples: SHM. SHM is nothing but we know that SHM. What is meant by SHM? Yes, simple harmonic motion. We are going to discuss about simple harmonic motion, vibrations, vibration body considering of motion is there. Then we are considering the force also. Next, hydraulics. Hydraulics also we are considering the external forces, which is depends upon the Newton's second law of motion. Kinematics is generally depends upon the Newton's second law of motion. What is Newton's second law of motion? Yes, exactly. F is equals to mv. That is nothing but a Newton's second law. Based on Newton's second law of motion only, kinetics has been done. We are going to discuss kinetics on Newton's second law of motion. First, what is meant by Newton's first law is very important topics. An engineering student should be every engineering student should want to know about what is meant by Newton's first law, Newton's second law, and Newton's third law. Okay, beware of that. It says that motion of a body. It states that Newton has been says that rest continues in the state of rest. Rest has been continuous and there may be state of rest. When the body is in rest, the state will be in the rest condition. When has been changes means when there may be applying of some force, when there may be forces acting, the body has been just convert the rest motion into motion. Now look at the cursor is rest. Now there may be no movement. Now the cursor is in rest condition. When there may be a movement, there may be movement in the mouse, there may be change in the direction. Whenever the external force is applied, there may be a move. That is called as Newton's law of motion. A chair lying on a floor will continue to remain unless we displace it. We just cursor, look at the cursor. Cursor is not moving here. Cursor is stable. Now the cursor is moves, there will be change in the body. Now you are moving the mouse, the cursor has been changes the. That is nothing but a Newton's first law of motion. Now these are Newton's first law of motion. Now these are at rest. These are at rest. Examples: A compelling 1, 2, 3, 4. 1, 2, 3, 4 should be at rest condition. They are not moving. And there may be external force. A is moving. Movement is there. When they hit 1, 2, 3, 4, it starts accelerating. It starts velocity. It starts moving. Now it starts moving. The rest has been changes. The position of rest has been changes. Whenever the rest has been changes, that motion is called as Newton's first law of motion. It is called as Newton's first law of motion. Next, Newton's second law of motion. Newton's second law of motion states that the rate of change of moment of an object is proportional to acceleration of a body. The rate of change of moment of a body is proportional to the acceleration of a body. We know that F is equals to mass into acceleration. Force is measured in terms of Newton. We are discussing about the forces, only the forces here. Forces acting on a body. That means the force unit is always in terms of Newtons. M indicates mass. Mass is measured in terms of kilograms. Mass in terms of kilograms. M indicates the mass. I note the colors. A indicates the acceleration of acceleration is measured in terms of meters per square. Meters per second square. Meters per second square is nothing but meter per second square. The unit of meter per second square is nothing but an meter per second square is nothing but an acceleration. Now this becomes kg. This is meter per second square. Now kg meter per second square is nothing but an What is that one? Very important scientist, that is called as Newton. The unit of force is. Now discuss about Newton's law. Very important, very easy. Everybody know. This thing is very known. When one body exerts force on second body, the second body simultaneously exerts a force equal in magnitude opposite in the direction of the first body. That means for every reaction there may be equal and opposite reactions. And there may be one body is exert one body is exert on second body. That second body is also exerts some force, equal magnitude and opposite direction on the first body. That is nothing but a Newton's law of motion. Now consider the force characteristics. What is meant by force? What are the characteristics? We are going to discuss about characteristics. Force is nothing but a push or pull on object. Force. What is meant by force? What are the characteristics of force? The force units are newtons. Now we are discussing about the characteristics. Force is nothing but push or pull of an object. Force is push or pull on an object. Some mass that can cause it to change its velocity. Velocity is nothing but acceleration. Change of velocity is nothing but an acceleration. A force is vector. Force is a vector quantity having both magnitude as well as direction, which means both magnitude as well as direction. You know that vector quantity as well as scalar quantity. What is meant by scalar? In Newton base syllabus we get what is meant by scalar quantity means having only magnitude but not direction. That is called as scalar quantity. What is meant by vector quantity means both the direction as well as magnitude. That is called as vector quantity. Okay. Mass that changes the velocity to accelerate, that is nothing but a. What are the four important characteristics? We know discuss about. First important characteristic is magnitude. Force consists of some magnitude, some value is there. Some value is there. That is nothing but an suppose we are hit somebody. When you hit somebody and when you hit somebody, now we are considering some magnitude is there, some value is there. Say 8 Newton or 10 Newton like that. That is nothing but an magnitude. Next, point of application. We are talking some point of application only. We are taking force. Now we are applying force on at that particular point. The particular point of application, that is called as one of the characteristics. Next, line of action. It consists of a line of action. It is moving it at some line of action. Direction. It consists of a magnitude as well as direction. Magnitude and direction. Very important quantities. Very important characteristics. Very important discussion about the law of transmissibility. We are in a rigid body. We are discussing about law of transmissibility. What do you remember law of transmissibility? According to this law, there is nothing but transmissibility law. The body of rest or motion. The body is at rest or motion of a rigid body. Only rigid body satisfies the transmissibility. No body has been obeys the transmissibility. Only rigid body, because rigid body doesn't change the position. That's why you are considering only the rigid body. States rest or motion of a rigid body is unaltered. When there may be change, in the position of a body, the rigid body doesn't change. The force acting on a body is replaced by another force. Whenever there may be no change, the force is changed. If the force has been replaced by another force of same magnitude and direction, but acting at anywhere on the body along the line of action of the force. That is called as law of transmissibility. Law of transmissibility is possible in engineering mechanics only. Because engineering mechanics is a subject which is dealing about only rigid bodies. That's why we are going to discuss about Transmissibility in rigid bodies. Now this is the transmissibility. Look at the diagrams with the transmissibility here. Now the body force is acting A, B. A, B is the line of action. This is the line of action, right? One of the characteristic force. Force is acting on the line of action here. F is the have the magnitude as well as direction. Now point A, the force is acting at point B. Assume the force is acting at point B. Now it has been replaced. Now the same force has been replaced, which is equilibrium. It may be equal to same body. The force is replaced with another force having same magnitude. The same magnitude is F only. Direction is also same. The direction is also same, which is acting at another point. That is point A. Now it is acting at point A. There is no position of a body. There is no change in the position of a body. If there is no change in the position of a body, such law is called as law of transmissibility. Law is called as law of transmissibility. I am showing another example also. Body AB pulled by a force P1 and P2. P1, P2 maybe which is around opposite in the direction. The two forces are in opposite in the direction. When equal to, now it has been replaced with the same magnitude P2 and P1. The forces are altered, which is equal to P2, P1. AB, the acting at point AB, which is equal to, now the two forces are replaced by some another point at point C. The two forces are acting. Now this body has been remains unchanged. There is no change in the position of a body. Then there is no change in the direction of a body. Then there is no change in the magnitude of a body. The body remains, because the body is rigid body. Now the body position has been not replaced. This body position also not replaced. This body position also not replaced. And there will be no replacement, and there will be no altered of a body, no alterations of a body. The body is said to be as the body is suitable for law of transmissibility. The body is nothing but a rigid body. Rigid body is nothing but which doesn't deform. That is called as rigid body. Only law of transmissibility is applicable for rigid bodies. Now, in this system, in this mechanics, engineering mechanics, we are going to discuss about different type of forces. Different types of forces are there. We are discussing about collinear forces. Discuss in next videos. Collinear forces. What is meant by collinear forces means the line of action of forces should be on straight line. Now the line of action should be on straight line 180 degrees. Now the line of action is about 180 degrees. Same line. Those are called as collinear forces. Remember tug of war. The game tug of war which is acting. The force is acting along a straight line. Otherwise in a rope. Force acting on a rope or a wire. That is nothing but an collinear forces. Whenever they are acting at an 180 degrees. Now this is a force. This is a force which is acting at an angle of 180 degrees. Such forces are called as collinear forces. What is meant by concurrent forces? Now the body is said to be forces. Now four forces are acting on the body. The four forces has been passing to a single point. Now the four forces are acting at a single point. Those forces are called as concurrent forces. Look at the body, two whites, weight is acting. Now three forces T1, T2, W say acting at point O, acting at same point. Those forces are called as concurrent forces. Parallel forces. What is meant by parallel forces means whenever they have been acting at a straight line, whenever the forces are acting parallel to one another, F1, F2, F3, F4. Four forces are there. Now four forces are acting parallel, one of them are parallel to each other. That means at an angle of 0 degrees. You know that parallel forces, parallel lines, the angle is almost 0. Now the angle is 0, angle between the forces remains 0. Those forces are called as parallel forces. Look at that. Here the boy is there, here the girl is there. Which is acting downwards, which is acting downwards. Now the forces are acting, the weight is acting. Weight is nothing but a force. The force is acting parallel to each other. Parallel to each other at some distance. Those forces are called as parallel forces. Those forces are called as parallel forces. Next, general forces, another forces, which is forces are called as non-concurrent forces. What is meant by non-concurrent forces means the forces which are acting and doesn't pass through a single point. Forces which are acting on a body doesn't pass through a single point. Such forces are called as general forces are nothing but non-concurrent forces. Such forces are called as non-concurrent forces. When they be not passing through a single point, then may be a producing of movement. Movement is nothing but rotation. Then there is producing of rotation of a. Now we are going to discuss about suitable discussion about collinear forces, concurrent forces. Collinear forces nothing but tensile forces, compressive forces. Concurrent forces, we are discussing about concurrent forces here, and parallel forces, and now concurrent forces. We are going to discuss about these three topics in Unit 1 of Engineering Mechanics. This is about the introduction of Engineering Mechanics, and it is the first video of Engineering Mechanics. Came doubts? Clarify it. Thank you for hearing the introduction about the mechanics. Very important topics of engineering mechanics for second year students of mechanical engineering as well as civil engineering. Every branch of students should go discuss about this.